So what we're going to do this morning is talk about some of the treatment options, setting up a treatment program. So we'll look at the CPM setup. CPM used for continuous passive motion to try to increase range of a joint. We'll also look at using the CPM function as a way to do some neuromuscular re-education or submax motor control training. And then we will look at the isotonic treatment setup and talk about setting goals and setting resistance and monitoring progress during an exercise. So we're going to go to the treatment setup. Once you've selected your client name, go to the treatment setup. And as you can see, yesterday we added the shoulder strengthening template, which includes the isotonic exercises for all the different shoulder movements. And then we also added the shoulder range of motion template. We did that yesterday, which includes the CPM setup activities for the shoulder. So let's look at shoulder internal-external rotation for CPM. So one thing that you can do in CPM is you can control the parameters of the exercise. So if I go back to the setup screen, I'm going to choose the modify option, and then that will let me make changes to the configuration of how the exercise will proceed. There's a forward motion and a return motion direction. So the forward motion would be the first direction of movement, and then you can set the speed of the movement for each direction. So the default is 10 degrees per second for each direction of motion. You can set that as low as 5 degrees per second for a very slow CPM motion. So if our first direction of motion is to try to work on external shoulder rotation, we can set that to 10 degrees per second. But in the return direction, we can set that a little bit faster to come out of the stretch position to return to the neutral position. The time of the exercise, it just defaults to 10 minutes, so I'll just leave that there for this demonstration. And then there's a pause time that you can set to have the machine hold the stretch position for a period of time to enhance the stretch process during CPM. So if you wanted the machine to push the person's limb into a stretch position and hold it there for 5 seconds, we can set the pause time for the first direction to 5 seconds. So when we go into external rotation, we'll stop, hold it for 5 seconds, and then return to the neutral position at 20 degrees per second. So at the neutral position, since we're not focusing on that part as part of the stretching process, we'll just put a 1 second pause there just to give the client an indication that the tool will start moving in the other direction again. The next one is the lever arm of the attachment. If you're just doing a CPM exercise where your objective is just the motion, we're not worried about what the forces are. So you don't need to put a lever length in there, you don't need to do the conversions. You can just accept the default force value, which should be enough to push the person's limb through the range of motion and hold it there during the stretch. So at this point, I'm just going to leave that without entering anything. The default side for these exercises is left. So if you're working with the person's right extremity, you can go to the side selection, and you can change it to right side if it's the other extremity. Once you have your parameters set, then just choose the Save option. And then go to the Treatment tab, which will then take you through the final steps of setting the range of motion for the individual. So as I mentioned before, for setup, there's a lot of different configurations you can use for particular patients, depending on what their needs are. You can have them do the exercise standing or sitting. You can do it at a small degree of abduction or a large degree of shoulder abduction. It just depends on where that person needs to be for the exercise. Right now I have the exercise head set to the number 3 position, which will let me put my arm at 45 degrees of shoulder abduction for the exercise, which is going to be comfortable for most patients. But again, if there's a limitation or if there's a need to do it at 90 degrees of abduction, you can certainly set it that way. So the first step then would be to press the start button. And that'll take you to a screen where you can set the range of motion of the activity so that the machine knows when to change directions. You have the option of setting a mid-range position, a start position, and an ending position. The mid-range is optional. It's not necessary to put that value in. But you do have to have a start position and an ending position. So to set the start position, just click on Set Start, and then have the person move to the start position. Actually, Chuck or Waldo, either one, if you wouldn't mind. It's just a lot easier.
Yeah, that's what I thought.
Yeah. If I was doing it with that. Okay. So we're going to have the start position at internal rotation, and I'll click on the OK button to mark that as the start position. And then I'll have the person actively go through as much external rotation as they can move comfortably. And then you'll hit Set Start Position. And then when you hit OK, it will lock that as the ending position of the activity. And then when you click OK one more time, it'll move the tool back to the start position in preparation to begin the exercise.
Nice. Korean. Whoops.
Right, so when you're ready to start the exercise, you'll press OK. And then the tool will start moving. In this example that we created, the tool is going to move at 10 degrees per second into external rotation. When it gets to that end point of the range, it will stop and hold the position for 5 seconds, and then return at 20 degrees per second back to that start position. It'll pause just for 1 second, and then repeat the next repetition. And this will continue for 10 minutes, or unless you press the stop button to end the exercise. So this is just a straight CPM. The patient is passive, so they're really not doing anything other than kind of just riding along with the tool as it's moving them through the range. So you can see that the machine is moving Mr. Wellington's arm out into the external rotation direction. It stops at that end point. 5 seconds, and then it comes back into the neutral position. If you want to change the range of motion during the exercise, because eventually the limb will loosen up, you can add degrees of range by using the plus button. So if I click on plus, every time I click it, it adds 1 more degree of range to the end point. Now if you're pushing somebody into a tightness in the joint, a tightness of the end range, what you usually see is the graph curving up like that. You'll see it go up because it's pushing into tightness. This line represents the force that the machine sees as it's pushing the limb through the range of motion. So that's a basic CPM setup where it's a very passive activity. The person is in position. The machine is moving their limb back and forth through the range that you designate to try to increase range of motion. When the timer reaches 0, it will automatically stop the exercise. Or if you press the stop button, that will also terminate the exercise. There is also an emergency stop button that you can use. You can have the person hold on to this so that if at any point they feel uncomfortable or if they think the machine is pushing them too far, they can stop the machine with an emergency stop button to end the exercise.
Or in this case, they can let go.
Or in the case where they're not strapped in, they can just let go and step away, of course. But many times with CPM, you're going to have the person strapped to the attachment or in the chair and position where they're not going to be able to walk away. So they need to have some way of stopping the machine if they feel that it's going to hurt them. So at the end, again, we can just press the stop button to end the exercise. And then save the results so that we have the information stored, and then the next time the person comes in, you'll be able to replicate the setup. You will have to set a new range of motion when they come back for the next day, because hopefully it's improved, and you won't want to use the old range of motion because it's better now. I'm going to go back into the setup screen and change a couple of the parameters, because the next way we're going to be using the CPM mode is more for neuromuscular re-education or a submax motor control training activity. So I'm going to bring up the patient name again.
We'll switch to right this time so it should be some. Actually, I want to do that because I can see the screen.
Yes, you need to be able to see it. So I'm going to modify the parameters now to make some changes to make this more suitable to a submax motor control train exercise. Again, you can adjust the speeds that you want. If you have slower speeds, it's easier for the person to control their force output, because for this activity, what we're going to ask the patient to do is to try to match their force output to a designated target range. And if the speed is slower, it's easier to do that. So when you start working with the person the first time or the first few times with this type of exercise, it's more comfortable to start with the slower speeds because it will help them be successful when you get started. As they start regaining control and regaining that strength control that we're focusing on, if you change to faster speeds, it makes it more challenging for them. It's more difficult for them. So that's one way you can vary the difficulty of the exercise, by changing the speed of the exercise. For this example, I'm going to set the speeds to 15 degrees per second, and we'll have the speed the same in both directions. For the pause time, I'll just put 1 second in each direction. Since our objective now is not range of motion, but it's to have the person actively participate in it as a strengthening exercise, I'm only going to put the pause time in there just, again, as an indicator for the person, so that they're aware that it's going to change directions and they can mentally prepare themselves for that. And since we're going to be dealing with force output in this particular setup, I'm going to enter the lever length of the tool so that I can enter the values then in newtons instead of newton meters. And then the last value that we can set is the target force value. This is the value that you're going to set that you want the person to try to achieve with each repetition as the tool is moving them through their range of motion. So the setup process is the same as far as range of motion goes. We're going to set a beginning and an end position. So,
resist or assist?
Right now, first repetition, nothing. Okay. Just let it move you passively through the range of motion.
Okay.
And then get that reading as far as the weight of your limb. So any value that we get, in this case it shows 10 newtons. Approximately 10 newtons is the weight or the force of the arm and the tool on the load cell. So to set a submax value for that, we can go to the target force and type in a value. His was 10, so if we want to start lower than that, we can maybe do 3. What happens if you go lower than the weight, the machine will not have enough force to be able to push the person's arm, and they'll have to actively assist it. So it becomes an active assist range of motion exercise with a target force to lift just the weight of their arm. So if you relax and you don't move, it should just sit there. It's not moving because it doesn't have enough force to lift. He has to help it, and you help it with just enough force so that you draw the line inside that target window. Then he's really just lifting the weight of his arm, being assisted with 3 newtons of force. So it's more of an active assist type exercise right now. You can change the target force while the system is active. So if you need to adjust this value to make it more appropriate for the individual, you can change it at any time. So if I wanted to make this more of a strengthening program where I'm teaching him how to control his strength through range of motion, maybe I want to set it higher than the weight of his limb so he actually has to now resist or eccentrically push against the tool as it's moving him through the range. So I'm going to set it to 15. So now I'm going to ask Mr. Weatherington to resist the motion of the tool and then pull up. But with just enough force so that the line being drawn is inside that target window. This solid line in the center is 15 newtons, and the dotted lines above and below represent plus or minus 10% of the target. So the objective of the patient is to try to control their force output as they're pushing against the movement of the tool or resisting the movement of the tool, to try to keep their force output curve inside that target window. To monitor how well the person is able to perform that activity, we look at the percent on target score, and this shows you what percentage of the time the person is able to keep their force output inside that designated target range. The better motor control they have, the higher percent accuracy they'll have. So right now the way our volunteer is doing the activity is he's resisting the motion of the tool. So he's providing an eccentric muscle load in each direction. And I can tell that by looking at the color of the line as it's being drawn on the screen. If this line is red, then I know he's resisting the motion of the tool, doing it eccentrically. If he moves in the same direction of the motion, it becomes concentric, and the line, go ahead and do a concentric, the line turns green. So if I see the green line, I know he's pushing in the same direction of the motion or doing concentric muscle loading. If the line is red, then I know he's resisting the motion of the tool, doing an eccentric muscle load. So you can prescribe to the person which direction you want them to control their force to get the benefit that you need out of the exercise. So you'll monitor the percent on target, and again, once they achieve a percent accuracy of 50% or more, you can then re-challenge them with a new resistance, a new target, or change the speed for the next time to make it a different exercise, a different way of controlling. So what this type of setup does is it helps retrain the person to control their force output as they're moving through range of motion. It's very good for neuromuscular re-education, working with stroke patients, CVA, head injury. Anytime they have to relearn motor control, this is a very good training tool to help them accomplish that. So again, the timer will run out when it's completed, or again, you can press the stop button at any time to end the exercise. So we will save the results. and then we can move on then to the next exercise. This?
Yes.
This is a representation of the force that the patient is exerting. So it's showing you how well they can control their force by giving you a real-time display of how much effort they're exerting against the movement of the tool. If the person has perfect control of their force, the line will be more flat. So what I would do for a new patient, if this is the first time you've done it, is the way I did it initially with Mr. Weatherington, is I would have it set up and let the machine move their arm through the range, or their leg, whichever limb you're using, and then you can take a measurement of how much the limb weighs, and then calculate a percentage of that to set as the initial target for training. So you're going to, again, be setting it at a level that's based on that person's physiology. One of the benefits of using this screen for that kind of exercise is that it allows you to set the machine up to move the person's limb through a range without any participation from that person. So you can do it passively initially, just to allow the person to get comfortable with the movement pattern that they're going through. And then using the force output feedback to teach them that, yes, they can exert load against the movement of the tool, but you could start actually very low and build up to the point as they start feeling more and more comfortable with their abilities. Yeah, when you're doing it just for the motion, you do not need to set the target. You can just let the machine move the person's limb without any participation of the person. What I would do is set them up in the CPM mode, so it's an entirely passive exercise, and make sure that the machine can push the person's leg into knee flexion to stretch that endpoint of the range, to try to increase range of motion, and so that scar tissue releases a little bit. It's going to be it's a slow process. You may only be doing a few degrees extra per day or per week, depending on what they can tolerate. But slowly you should be able to increase that person's range of motion.
But that's where also using that dwell time at the end of the range is helpful. Bring them into flexion and then hold it for a few seconds, and then bring them back out. Bring them back in and hold it, and then you'll eventually be able to start stretching out that scar tissue. Good.
Okay. I'm just going to restart it again so we can get the machine moving. When I started, I'll just ask Mr. Weatherington to not exert any force on the handle, just to let the machine move him. So this would be the graph as it looks like if the person's being passive. You just see a build up to the point of the weight of the limb. It stops, and then it comes back down again. Now if I wanted him to actively assist or apply force to the handle, you see our target right now is at 15, so the graph will rescale. So go ahead and resist. So you see how the graph just went up. I know he's actively participating in it now. And if he keeps his force output inside this target window, I know he's actively participating. Because if he was just doing it passively, I would just see a graph here that looked like this.
So that's passive. This is active.
And that's active. So you can tell by the way the force, this is a representation of the force that the machine sees that the person is exerting during the exercise. So what we're going to do next is a similar type of exercise to what we just did, except it's going to be force control output, but with no motion. So we're going to do it in the isometric mode. So I'm going to create a new exercise to do a isometric grip exercise with a target force, again, to help teach force control output, but it's going to be with no motion this time. So in the isometric exercise setup, you can see right here there is that place where you can enter in the lever length. Actually, no, that's this one. And this is the target force. No, this is the time. This is the time.
In seconds.
Yeah, this is the lever length. This is the time. This is
the
your target
force.
Okay. So the time for this exercise is how long you want that person to hold and sustain that isometric contraction. You can set that as low as 6 seconds and as high as, I think it's 999 seconds.
Wow. Please don't.
So we'll do a 10-second trial for this example. For the target force, there's a couple ways you can approach setting the target force. You can just simply set it to a value that you want to use for that person. So if I wanted to say go to
50.
Okay, I was going to do 20, but we'll do 50 for it. 50 newtons, which is about 5 kilos. I can preset it to that value, save the setup, and then when I go to the exercise screen, so there's our target of 50 newtons, which again is about 5 kilograms. So again, when you begin the exercise, you'll ask the person to exert force against the handle. In this case, we're going to do a grip, and they'll watch the screen and just exert enough force so that when they build that torque curve, very similar to what we were looking at in CPM, they'll be able to keep it inside that target range, which will be 50 newtons plus or minus 10%. So if you know the value you want to use, you can just simply type in that number, and that becomes your target for the exercise. If you don't know the value you want to use, you can take a percentage of their maximum. There is an option to do an isometric trial on the screen where you can actually test the person to their maximum, and then it'll give you a calculator to figure out the percentage of maximum that you want to use as the submax target force. Also with the grip tool, you do need to set up the handle to the proper position depending on whether you want a small grip or a wide grip. This can be set to 5 different positions, 1, 2, 3, 4, and 5. Those correspond to the 5 rung positions of a standard hydraulic dynamometer, like a J-Mart dynamometer. So if you want to use, say, position 3 for grip strength exercising, you can put the pin in number 3, and when you push the handle up to touch the pin, that gives you the equivalent size of position 3 on a grip dynamometer. So if we wanted to do the static trial, I can press this button to do an isometric trial. It locks the tool into the isometric mode, and you just ask the person to grip as hard as they can. And it will take a measurement of how much force that person was able to exert, and then give you that calculator where you can type in a percentage. It'll figure out that percent value, which you can then use as your target for that person. The default value is 75% of maximum, so it's still going to be a sub-max level. If this is the first time you're doing this exercise with somebody, if they're very early on in treatment, 75% might be a little bit high for the initial setting. I would probably reduce it to 50% for the initial isometric target. So I'm going to change that to 50%, and then press enter. And you see when I press enter, it recalculates that value then to 50% of what the maximum was. And when you press OK, it will take that value and set it as the target for the exercise. So you press start, ask the person to grip, and the force, the blue line you see being drawn is the force that the person's exerting against the handle. So you want them to be able to watch the screen so that they learn how to control their force output and keep it at that level. The way this exercise is scored is, again, we look at the percent on target value. This is the percentage of the time that the person was able to maintain their force output in that prescribed range. Each trial is represented by a different colored graph, and it will let you do, I think, a maximum of 15 trials. So it's a very quick setup, and it's just a simple exercise. There's no motion in the tool. It's just strictly force output. So we've looked at the CPM setup and treatment, and we've looked at the isometric exercise and treatment. The next one we'll look at is isotonic exercise setup. Right, so based on our evaluation results, we'll say that we determined that this person has a strength deficit in doing shoulder external rotation. So now we want to configure an exercise program to try to increase the strength for that muscle group. We'll use the 701 tool that we've been using and put the lever length in there. And the same question now comes up that we just answered earlier regarding the target forces for isometric and CPM. How do you know what resistance to set for this person the first time they do the exercise if they've never done that exercise before? How do you know what an appropriate level is? Well, there's a couple ways you can approach that. I mentioned them in the PowerPoint yesterday. One of those is to set it at a very low level and have the person start exercising. While they're exercising, you can make increases until it gets to a level that they tell you is comfortable for them. The problem with that is that they could be self-limiting, they could not be sure what they can actually do, so they'll tell you that it's comfortable when they could actually tolerate more and get a better result. So a more objective way of setting the resistance is similar to what we did in isometric exercise, is to do that static trial, take a measurement of what his maximum force is, and then set the dynamic resistance at a percentage of what his exercise or his maximum strength is. So to do the static trial, I'll put the person about midway through range, and then when you hit the static trial button, it locks in that position, and then I'll just ask Mr. Weatherington now to push out against the handle as hard as he can into external rotation. So go ahead and push out, push, push. Okay, and relax. So similar to the screen that we saw in isometric, it's taking a measurement of how much force you can exert maximally, and then it calculates the percentage of that to use as the daily treatment setting for resistance. Now in a dynamic exercise, the default is 30%. Because what we're doing here is we're taking a maximum measurement at one point in the range, and then we're going to calculate a force that he has to exert through his whole range. So it needs to be a lower value because, again, you're weaker at the ends of your range. If we did like an isometric where we take 75 or 50%, that might be too challenging for the endpoints of his range. So we're going to go a little bit lower. We're going to go to the 30% level, which for most patients is going to be a comfortable but challenging resistance level. So we're going to hit OK. It'll take that 26.58 and set it then as our dynamic resistance for this exercise. So when we press the start button, you ready to start? Okay, whenever you're ready. And then slow down, and push out, and resist it down. So the first 5 seconds of the exercise, as we've seen in other screens, is always the 100% performance level. Every time an additional 5 seconds goes by, we compare how much work they did in that 5-second cycle and display that as a percentage. If the person is working consistently, these bars should be similar in height. at least within the target range of 100% plus or minus 25%. A typical exercise time at 30% of their maximum is usually 60 to 120 seconds. So you can look for signs of fatigue by looking for substitution patterns, facial expressions, or if you start to see a drastic decline in power output, that's a time to stop the exercise.
Or self-stop.
Or self-stop. So that's when you'll stop the exercise for the day. So the first time you do an exercise in the isotonic mode, we're not setting any goals, we're just letting the person work as long as they can until they reach the point of fatigue. We can then take the information that we've collected from that exercise and determine what the appropriate goal is for that person for the next time that they come in. So we're setting the goal based on their current performance level. It takes all the guesswork out of it. It's always based on that person's performance. So in this particular result, the person exercised for 74 seconds. Their work output was 761 joules and 5,566 degrees. That's the distance that the tool moved during the activity, accumulating with each repetition. I'm going to go ahead and save these results. And then determining what goal you want to use for that person, you can use either the work output number in joules, you can use the distance measured in degrees, or you can use time measured in seconds. Any one of those three numbers can be set as a goal for the next time the person comes in. So once you've chosen the value you want to use as your goal, in this example we'll go ahead and use work, which was 761 joules. I'm going to go back to my treatment setup screen. And then choose the modify option to enter in that goal. So in the center of the screen where it says goals, you have the choice of doing the automatic mode, which is what we just did. It means the exercise will continue until you press stop. Or you can do work, distance, or time. So you'll just choose which one of these you want to use. In this case, we're going to use work. And then in the box where you're designating the goal, you can put in the number of joules that you want that person to achieve during the next exercise. Now his result was 761. What I would probably do for this person for the next time is just round that up to 800. So I'm going to go ahead and save this.
Go ahead and do the next one.
Yeah, we'll do the next one too.
Can I switch to shoulders?
We might do internal rotation next. We might do a flexion and an extension exercise. But we could go through each one on this list using the same process. Do an isometric trial to figure out their maximum, take a percentage of that to set the exercise level, have them work to fatigue against that level, and then set the goal for the next session based on the results of that exercise. Once you've completed the session for the day, you'll exit out of that person's record, go do something else with them or send them home for the day. And then when they come back the next day, we want to repeat those exercises. We want to see what he can do today compared to what he did the last time he was here. So we will select that person's name, bringing up their record. We'll go to the treatment setup. Just make sure that the appropriate template is selected, because you can assign multiple templates to an individual. If it comes up to the template that you don't want, if you want a different one, just go down to the bottom where it says exercise templates. Select from the list the template that you want to use that day, and then it will load that series of exercises. So when I bring up the exercise for the next time the person comes in, at the bottom it's going to show you the results of the previous session. So here it shows the last time he was here, he did 761 joules of work, 55, 66 degrees, any exercise for 74 seconds. It automatically set the resistance the same as it was last time, so you don't have to do any changing of the resistance. You can just keep working at the same level. And now it's showing us here that the goal is going to be 800. Also with the work goal, it displays these two cars to help provide feedback in real time for the patient as to how well they're doing the exercise that day compared to last time. When you start the exercise, the bottom car will start moving across the screen at the rate at which the person completed this exercise. So it'll be like repeating what that person did on that bottom line. The top car will move across the screen at the rate at which he's doing the exercise right now. So the objective for the person, for the patient, in order to ensure that he's doing better today than he did yesterday, is to try to keep his car, the race car on top, ahead of the car that's on the bottom. Okay, so we're going to go ahead and start the exercise so we can do this. We're assuming we're on day number 2 here. Good there. So again, go out and then slowly come back down. Push out and slowly come back down. Very good. If the person cannot finish the goal, if they get fatigued before the car gets to the end, you can just press stop at any time to end that session. We're showing his current values. When it reaches 800, it will stop the exercise. Also, after the first exercise and each subsequent exercise then, it's going to pop up this comparison chart to show you the actual numbers of what the person accomplished today compared to the last time they were here. So the last session the person participated, they did 761 joules of work and 10.3 watts of power. During this session, the person did 17.8 watts of power and 800 joules of work. Work increased 5%. Now that 5% change is something that we as the therapist control because we set work as the goal. So the change from 761 to 800 is something I set, so I controlled that 5% increase in work output. But the power output is a change based on his actual performance. And you can look at that number, and again, using that speed protocol, if you see a power increase of 10% or more, the suggestion is you, for the next time the person comes in, you increase the work goal by 10%. So his power increased 72% from last session.
Got loosened up.
So that would be a good indicator now that he did very, very good today, quite a bit better than the last time he did this exercise. So for the next time he comes in, I want to re-challenge him now with a new work level to make him do a little bit more. So once you've collected your exercise data, maybe you've done this for a couple weeks and you want to see what kind of progress that person's doing overall. In the report section, you can retrieve a progress graph for each of the exercises you have on that person's routine. Treatment options. And it shows you a field for the isometric exercise, for the isotonic exercise, for CPM, and isokinetic, if you've done any of those. So if we're looking at the isotonic exercise that we did, 701 external rotation, if I select that, you can see the 2 exercise sessions that we just finished. If we've done this 10 times, there would be 10 items listed under that tool number. If we've done more than one tool, that would also be a separate line item in that window there to choose from. Right. So this was the left side external rotation. The first day of exercise is the first line in the chart. The last day into the exercise is the second line in the chart.
Lines are power and work.
Oh, yeah. This is the power output, the work output, and this is power, this is work, this is the resistance that they were exercising against. The chart right next to that, to the right, tells you whether or not the force that the person was exercising against changed over that time period, and by what percentage. And it shows you the percent change for work and percent change for power. So from the beginning to the end session, this person's work output increased 5% and their power increased 72%. And then the graph on the top shows you work and power. For the first session, second, third, fourth, every session will be represented on this graph, showing you their percent change over the course of the entire treatment sessions. If you want to create a custom exercise, as opposed to using one of our predefined templates, which focus really on isolated body areas, but there may be instances where you're going to want to set up an integrated activity where you're doing a work simulation. Those exercises you would have to create because there's just too many of them for us to pre-create them in your software. You'll have to build the ones that are going to be appropriate for your patient population based on the kind of work activities they do. Just to quickly go through that process, let me go ahead and bring up this blank template. Almost blank. So when you select new, oops, I hit modify. When you select new, again, it's asking you if you want to select from one of our existing templates or do you just want to create a custom exercise for the current template that we're in. So we'll select that second option. And then it just opens up these tabs so you can choose what mode of resistance you want to use. So if you want to create an isotonic exercise, or an isometric exercise, an isokinetic exercise, or a continuous passive motion exercise. The most common setup in exercising is isotonic. Now, that's the way activities are performed in everyday life. That's the normal way muscles move. So probably 90% of your exercises will be isotonic. The other 10% will probably be either isometric or CPM. So your first choice in creating a new custom exercise is to select whether you want the concentric muscle load or the concentric eccentric muscle load. So I would choose concentric, and then I would choose the attachment. I'm just going to choose other. That lets me select 901, which is the tool that I want to use for this sample. And then we're going to go to side selection. Are they using their left hand, right hand, or are they using both hands together? No shoveling, two hands, so I'm going to select both. The rest of the parameters include setting the lever length, which it will do automatically depending on what tool you've selected. Entering in the resistance you want to use. If you know what it is, you can set that. If you don't know what it is, you can set it when you get to the exercise screen when you're working with the patient. And then, of course, the goal option, which we discussed. The first time you do an exercise with somebody, I always recommend leaving it in the automatic mode, which means the exercise will just continue until the person gets tired. So when I hit save, it adds that exercise to the list, and then I can select it, go to the treatment screen, Get the height set appropriately. And when you're at this screen, you can set the resistance if you know what you want to use. Say, for example, we want the person to be able to shovel and lift 10 kilos. 10 would be 100 newtons. So if I'm going to be pushing this direction, lifting, that's clockwise rotation. So in the column for clockwise, I'll put 100, which is 10 kilograms. If you don't want any resistance in the return direction, just because it's just gravity bringing the weight of the shovel back down, I can leave the counterclockwise resistance at a very low level. So I can have resistance in only one direction. And then when you start the exercise, you'll just have the person doing the exercise until they get tired. To get my exercise for today. That's enough. Press stop, and then going through the same process, look at your values for that exercise, determine what you want to use as your goal, save that result, go back to setup, modify, we'll choose work, and round it up to 1500. Save that. Now it's ready to go for next time with a goal set based on my results today. And if we go back to the treatment screen, if we were coming in for the next day, it shows previous session, again with your race cars to provide feedback as to how well the person's performing today compared to the previous day. So let's take a look at some of these tests and how they're performed on the Primus system. Let's do we'll do the bell curve test first. That's a fairly quick one to do. So when you assign that test to the person, it shows that we're doing the grip test and we're doing left side and right side. The default parameters are to do 3-second trials. To shorten the test, to make it quicker, I'm going to change it to just 5 trials. That way we'll just be doing 1 trial at each run position. So the typical setting for this test is to adjust the height so that when the person is grasping the handle, the elbow is at 90 degrees of flexion. Okay. So the first test position is position number 1. Go ahead and go to the evaluation tab. So it's going to show positions 1, 2, 3, 4, and 5 for the left side and the right side, and we'll alternate back and forth. So we'll do trial 1 left, and then we'll do trial 2 on the right side, then we'll change it to position 2, and then repeat the process until we have all 5 positions done. So once you have the tool set up in the test position, hit the lock button. So that locks it then into the isometric mode where it will not move. But it will be recording how much force the person's exerting on the test. So again, we'll start with left side. Pay no attention to that. So we've captured the peak for left side, position number 1. Now we want to do right side. If you just click on or touch anywhere on that graph, so the yellow highlighting moves over, then we're going to be testing right side. So now I can start the test, have the person step to the side, and do the same test for right hand. And then we're going to switch back to the left side. If you unlock the tool, then that lets you transfer the pin to position number 2, move the handle out to position 2, and then lock it again. And now we'll do the same thing for left-handed. And then switch to right. And then we'll go back to left side, unlock. 3. And then right. So you can see it's capturing the peak value during that trial. And then we'll do number 4. And then one more time for position 5. So you can see how the curves of the 3 trials generally forms a bell curve. But again, the expectation is that you're weaker at the ends of the range of motion for your fingers. You're weaker when the fingers are tighter gripped and when they're fully extended. So position number 1 should be less than position number 2. Position number 5 should be less than position number 4. And then again, positions 2 and 3 tend to be the stronger of the 5 positions. Most people have their strongest in position 2, but there are some people with larger hands where their power or their maximum grip position is the 3rd position. Now the other test you can do, if we go back to our templates, is the rapid exchange. This one defaults to 10 repetitions. There are different versions of this particular protocol. Some versions say that you should do 6 trials, some say that you should do 10. It just depends on which one you're following, which ones you're more comfortable with. Both of them follow the basic same process though. You're rapidly changing back and forth between left and right with the handle set to the power position that was determined by the previous evaluation. So for my hand, I was strongest in position number 3. I would set the test position I couldn't count. I was too busy focusing on my strength. So the typical pattern that you see for this test, because you're doing it multiple times, and for that reason you're introducing fatigue into the test. So the expectation is you should see a slight decline in force as you progress through each of the trials. If you don't see a decline, or if you see an increase, that's an indication that they're probably not squeezing as hard as they can, because you don't get stronger when you get tired, you lose strength. you become weaker. So that's another consistency of effort type test you can do to develop your profile or pattern of behavior for the individual. Looking at the next one, that test is the line graph test. What it does is it documents force output over time. So instead of just looking at the peaks, which is what we were recording in the previous test, just the strongest that the person could exert during the trial, what we're going to be looking at is their pattern of strength over an extended period of time. The build up to maximum, how well they're able to hold maximum, and then the rate of fatigue as they begin to get tired. So it's going to give you some additional information about their effort. The default setting for that should be 6 seconds. The tool selection, grip is the other one, right? This one? No, it's this one. Grip. And left. So it's 6 seconds, 3 trials. This other information, rest time, it's optional. If you want to put a timer in there so that it counts the time between trials, you can do that. Or you can just look at your watch. That's what I do. But if you want to put it in, you can. I believe this is the target. That's the setting that we used for the isometric exercise, where you do a submax trial in exercise. That's what that setting is for. But we're not concerned with that right now. We're just doing maximum. So everything is entered. We'll go ahead and save those parameters. And then go to the test screen. So the way this test works is you instruct the person that the tool will be isometric, so that when they squeeze it, it won't move. But they should apply their maximum strength and then hold it until the end of the trial, which is for 6 seconds. So they squeeze it hard as they can, hold it, and then when the 6 seconds is up, normally you hear a tone, but I didn't hear it, it ends, then you give them a rest. Right, so when you're ready to begin the next trial, again, click on Start and instruct the person to begin. Squeeze as hard as they can, hold it, and then at the end, tell them to relax. And do the third trial. Okay. Right. Hard work. Right. So what you look for at this test in determining whether this person is probably giving you their best effort is there's really 3 criteria you can look at. One of those is just the general shape of the curves. You should see a similar pattern between the 3 trials. You should have a similar shape to them. The second thing you look for is at what point during their contraction did they reach their maximum strength value. That's represented by the X on the graph. So on trial 1, it was at a little before 2 seconds, and on trials 3 and 4, it was closer to 3 seconds. They're about 1 second apart. So normally you want to see those grouped together. And then the third criteria you look at is the coefficient of variation. And for some reason it's a little bit hidden on this screen, but it's right there. And I think if I print the report, it'll put it up on the screen so we'll be able to look at it and see what that number is. So the coefficient of variation is 7.2%. Again, you look for that value to be less than 15. So there's 3 criteria you look at this test in determining consistency. The shape of the curves, the point the person reached their peak force output, and that the coefficient of variation is less than 15. And you can do this test with virtually any isolated joint function. The last one that we have built into the system is the alternating trials test. I'm sorry, the maximum voluntary effort test. That one automatically loads a series of 10 tests on the list where you test both right and left for each of those 10 tests. This is based on a published research protocol that was developed by Leonard Matheson on VTE equipment. And it has 5 specific tools that you have to use. Those tools include the this is tool number 302, the large knob, for measuring supination pronation. It uses the 2 different size screwdrivers, 504 and 502. Uses the 601 tool for supination and pronation. And then the last tool is the 701, and then we look at wrist flexion and extension for this tool. So the first tool on the protocol is the 302. If I go to the test screen, it sets it up to do left, right side supination, then right side pronation, and you alternate back and forth between those directions. So the hand position is you have the person place their hand on the top of the handle like this, so their hand is in a pronated position, and then adjust the height so that their elbow is at 90 degrees of flexion. Once you have the height set for the first tool, you leave it at that height for all 5 attachments. So there's no more height adjustment necessary going through this, you just change tools. So the first position is with the hand on top in the pronated position, and they try to rotate the tool into the supination direction. It's not going to move, it's isometric, but it'll be recording how much force they're exerting. For the second trial, when we do pronation, they take their hand off the handle first and then move it into the supinated position and try to rotate it into the pronation direction. After you've given the instructions to the client and made sure they understand what they're supposed to do, have them place their hand on the top of the handle. You'll hit the start button and ask them to turn as hard as they can until the tone. Then they remove their hand, place it on the bottom, and then you'll transfer the graph to pronation, and then hit start. Wasn't ready. And do pronation. Okay, and then again, hand on top. To do supination. Supination. And then one more in pronation. So that gives you 3 trials. It gives you a coefficient of variation on each side, so 12.7, 5.3. You'll make a note of those. In addition, it does give you the percent difference between supinators and pronation, 22%. That's really not an objective of this test. We're not concerned with that difference. In other words, it shouldn't be a specific value, but it does give you some additional information about that person's abilities. So we would save the results. Which is the same tool, but now we do left. So then you would set them up and do the same thing, left, right, or left, supination, pronation, back and forth, same process. And then next test, take you to the next one on the list. Now this one changes to the small screwdriver, which is number 502. This one. And the basic test procedure for this screwdriver is pretty much the same as it was for the 302 tool. You start with your hand on top, trying to rotate into supination. Then they place their hand on the bottom to try to rotate into pronation. So it's 1 trial in each direction, alternating, 3 trials in each direction, alternating back and forth. And then you switch and do the same thing with the other hand. Next test is the larger screwdriver, number 504. Again, you position it so that the flat surface is parallel to the floor and ceiling. And then exactly the same thing. Hand position on top to do supination, hand position on the bottom to do pronation. So you're actually 4 of these 5 tools all look at supination and pronation. The last one, 701, is the only one that does a different muscle group, which is elbow flexion extension. The 4th tool on the list is the 601 handle. For this one, you position it so it's perpendicular to the floor, and they place their hand on the handle, and on this one you change directions of force, but they don't have to change their hand position. So the first direction would be to try to turn it into supination, and then they just go into pronation without taking their hand off the handle. The last tool on the list is 701. Is for doing an elbow flexion test. It tells you to set the lever length to 8.9 centimeters, and that's referring to the scale that's printed on the tool. So you just adjust that so it's at 8.9, or you can just set it to 9. Close enough. And the positioning of the handle should be in the closer position, the B position. Actually, that's the A position. So set up this attachment so that the bar is parallel to the floor. And you'll start with the right hand, doing isometric elbow flexion. So they're pulling up against the handle. And then they place their hand on top, so they're changing hand position, and then pushing down against the handle. So then you alternate pull up, flexion, extension, flexion, extension, flexion, extension. And then repeat left side. That gives you 4 more coefficient variations. Once you've completed all the tests and you have all of your scores in that form, you can then compare them to the cutoff points specific to each tool, to each direction of motion, dominant versus non-dominant, and also male versus female.